Hi everybody, coming to you live from my living room. Alright, we're going to go ahead and start right with direct variation. Now, direct variation is a pretty straightforward concept here. Okay. As a matter of fact, this slideshow is 2 slides long. So here's what we're going to look at. We're going to be able to identify an equation that models direct variation, first of all. We're going to be able to use direct variation, an equation, to solve a problem. Okay, well here's all direct variation is. It's an equation of the form y equals a times x. That's it. Okay, so you don't have to get too crazy about it. Here's a direct variation equation. Y equals 2x. Y equals negative 5x. Y equals 1.5x. Those are all direct variation equations. Now, really, what are these? They're lines, right? Y equals 2x is a line of the form y equals mx plus b, where b is equal to 0. Y equals mx plus b plus b. Okay? Really, what is this? It's nothing more than a line that goes through the origin. So every direct variation problem, every direct variation equation has a shape like this. Boom, right through the origin. Or, if we do another one in pink, let's say, like that. Again, not drawn terribly well, but going through the origin. Okay? It's a line that goes through the origin. That's all it is. Okay? And for direct variation, we typically use the letter A rather than the letter M, but they mean the exact same thing. A, M. Doesn't matter what letter we use. Okay, here's the language. And this is really what's the important part, because you all know how to use lines at this point. Okay, we're obviously not making the mathematics more complicated. We're just trying to introduce some language. So in this case, we'll say that y varies directly with x. Okay, you've probably heard that before in life. You know, this varies directly with this. All we're saying is that to get from one value to the other value, we multiply. Direct variation simply means that if two things are directly related or vary directly with one another, it means that to get from one number to the other number, we multiply. That's all it is. Okay? So, the only thing to remember is that instead of calling it the slope in this case, it is the slope. Okay? But we call it the constant of variation. Okay? And again, it is a slope. It's fine to call it m, really. But in the context of a problem that we're thinking of as a direct variation problem, we call it the constant of variation. Okay, let's look at an example so you get a sense of what we mean. Here's a pretty simple example. Okay? Suppose a rocket is launched into space at a velocity of 600 miles per hour. Since space is a vacuum, as long as the rocket does not encounter any obstacles or any kind of gas or anything, it's going to continue at that rate, right? Okay. So let's write an equation that expresses the distance d that the rocket has traveled at any time t. Okay. Now we just remember this equation: distance equals rate times time. That's the equation we're going to use. Okay. Now we have a rate. The rate is 600 miles per hour. Okay. And if we have time in hours and distance in miles, then we have our setup here. So let's write an equation that expresses the distance at any time t. D equals 600 t. That's all there is to it, really. Okay. Now, the only reason this is special is that we're introducing language. Okay. This is just a line with a y-intercept of 0. So now I can say that distance varies directly with time, and the constant of variation is 600. That's all we need to say. How could I use this to solve a problem? Well, if I told you that the rocket had been going for 2 hours, okay, could you tell me how far it had gone? Okay, what I'm saying here is that if the time were 2, could you tell me what the distance equaled? Well, sure, right? The distance will be 600 times t equals 2. That's 1200. Okay. And that's all there is to direct variation. Okay, it's really lines. You know how to do lines. I know you all know how to do lines. All we're doing here is introducing some vocabulary that can help us express mathematics in language. Okay, good work, everybody.